In the last two sections of Chapter 6, we're kind of switching gears, and instead of talking about linear equations, we're going to talk about linear inequalities. So by the end of this lesson, you should be able to graph linear inequalities and then write and use them to model real situations. So let's think back to what we know. Inequalities are a way to compare two expressions, and we use all of our different alligators, the less than or equal to, greater than or equal to, less than, and greater than. We have done this part before, and these ones we graph on a number line. So I'll give you something like x is greater than or equal to 3, and you would graph this. So you'd find 0 and you'd find 3. We did the closed-in circle, and we'd shade that way. Now these are a little different because they are linear inequalities. So the word line is still in here, so we're still going to draw a line. But this time we're not going to draw an equation. It's not going to be equal. So the difference is this is a region of the coordinate plane that has a boundary line. This we graph on a coordinate plane instead of a number line, which is an XY grid. The awesome thing about this is, just like the regular inequalities we've done, is there are infinitely many solutions. So back here when we first talked about these ones, any number bigger than 3 works. 4, 5, 6, but also like 650, and we could go on forever. There's infinitely many solutions, that's why we have the arrow. This time our solutions are still going to be pairs, but we're not just going to have one pair, we're going to have infinitely many pairs. Because what we're going to end up doing is we're going to end up drawing a line and then shading stuff in. So any point in that green shaded region will work. So this kind of sums up what we did. The thing that's going to be a little different is sometimes you can graph things like this both ways. So on a number line, if x is less than 1, we'd have the open circle, we draw it this way. But remember, this is also a line on the coordinate plane. It's a straight up and down line. We shade it so that we have all the values that are less than 1. So this kind of talks about the two vocab things that we did. A linear inequality describes a region of the coordinate plane that has a boundary line. The solutions are the coordinates of the points that make the inequality true. So we're going to draw two different types of lines here, dashed lines and solid lines, just like we had open circles and closed circles. If you see a dashed line, a point that is on this line is not a solution. So like this point, not a solution, not a solution, not a solution. But everything over here is. Where if you see a solid line, all of these points on here are solutions, and they will work in the equation. So this is the stuff that we know right here. When you graph inequalities on a number line, we have two different symbols. The greater than or the less than is open. Greater than or equal to or less than or equal to is closed. Today, what we're going to do is those symbols still get grouped together, so the greater than or the less than, but this time you make a dashed line. If it's greater than or equal to or less than or equal to, you make a solid line. And then our symbols, think about these symbols, less than or equal to. When we drew our circles, we would go everywhere left. Oh, sorry, this is greater than. I read it backwards. So we'd go right. This time, when we want things greater than, we're going to shade above the line. And before, when we had less than or equal to, we drew the arrows that way to the left. This time, we're going to shade below the line. So we'll start off pretty basic. Determine whether the ordered pairs are solutions to the inequality. So think back to any time we've ever plugged in a point. This is your x value and this is your y value, and we're trying to see if it makes this equation true, if it makes it less than 15. So let's plug in 2 for x, and we'll plug in 5 for y, and see if it's less than 15. So we get 4 minus 15, is that less than 15? Negative 11, less than 15, it is. So that means that this point would be in the shaded in region. Let's try one more together. Let's try 0, 0, nice easy one. Plug in 0, it's a minus, not a plus. We get 0 is less than 15. Yay, that works. So that would also be in the region. Now the thing that's different is just because we find one solution doesn't mean that we're done. There is infinitely many numbers here that we could plug in that would be less than 15. Because before, remember, we would want it to be exactly equal to 15, which there's only a few things that you can plug in to make that happen. So there is only one method to solve linear inequalities. It's just graphing. There's no elimination, there's no substitution, we can only graph. So the first thing you should do is write it in slope-intercept form. And the reason we do this no matter what is so that we can see where to shade. So remember, y equals mx plus b. Graph the inequality just like you would graph a line. Remember, we used a dashed line if it's only less than or greater than. And we use a solid line if it's less than or equal to or greater than or equal to. And then we can use a test point to double check that we shaded in the correct thing. I love to use 0, 0 because it is very, very easy to plug in. So let's graph it. First thing I notice is it is in y equals mx plus b form. So I'm going to pick out my important information. Remember, this is my y-intercept, and this is my slope. We like to write it as a fraction. So I'll start with 0, 2, and then go up 1, 2, 3 over 1, 1, 2, 3 over 1. I could go down 3, backwards 1, however many points I want to make. And then, before I connect these dots, let's take a look at our symbol. It is a greater than symbol. That means that I need to draw a dashed line. So instead of connecting these just straight up and down with a solid line, we need to connect them and dash it. So it should be something like this. Make sure it is really obvious for me to see that you are dashing your lines. We still get arrows on either side. And then stop and think about what this says. This says that I want all the y values that are greater than this line. So take a look at your y-axis. Where are your y values greater than this line? Well, hopefully you said all of these y values here would be bigger than this line. Down here, they'd be less than the line. So that means that the side we are going to shade is going to be, let's get a different color, everything over here. This is where all of our solutions are. Now we can pick absolutely any number in here and it will work in y is greater than 3x plus 2. Now remember, we had the test point, so if you struggle with knowing where to shade, I would suggest plugging in 0, 0 all the time. Now right now, for this equation, we would want 0, 0 to not be true because 0, 0 is not in the green shaded in part. So by plugging this in and checking it, I'm making sure that it is not included. So this says 0 is greater than true. Sorry, 0 is greater than 2, which is not true. So that means it's good that it's out here and it's not in the green shaded part. Let's try another one. This one's in standard form. We could find the intercepts, but the x-intercept is going to be a little messy. So let's change it over and put it in y equals mx plus b. Now one thing that we have to remember here is all of our inequality rules from before. I'm going to divide everything by -5 in order to get y alone. So hopefully some light bulbs are going off in your head that when you divide by a negative, you have to remember to flip the sign around. Still holds true no matter what we're doing. And then we go to graph this just like we would graph any other line that we have ever done. So I'm going to find -2, and then I'm going to go up 1, 2, 3, and over 5. 1, 2, 3, and over 5. And then I can go backwards down 1, 2, 3, over 5, 1, 2, 3, and over 5 more. Now before I connect these dots, I'm going to stop and think about what kind of a line I have here. So because it has the equal sign underneath it, I need to draw a solid line. So just like any other line that we've ever done, draw it solid. Now I need to figure out where to shade again. So you can stop and think about it, that I want all the y values greater than or equal to our line, which would be all these guys here. So that means it's everything up here is a solution. Absolutely every single one of these points. Or you can do the test point thing. So let's plug in 0, 0 again. This time though, 0, 0 should work because it's in the side that we shaded. So is 0 greater than or equal to 3/5 times 0 minus 2? So the awesome thing about 0, 0 is this goes away. So is 0 greater than negative 2? It definitely is, so we know we shaded in the right spot. So story problem, and then we're done. Suppose you plan to spend no more than $24 on meat for a cookout. At your local market, hamburger costs $3 per pound and chicken wings cost $2.40 per pound. Find 3 possible combinations of hamburger and chicken wings you can buy. So we got 2 things we don't know, just like the story problems we've been doing. I have pounds of hamburger and pounds of chicken. So I know each pound of hamburger cost me $3 and each pound of chicken cost me $2.40, and I can spend no more than $24. So I can spend less than 24 or exactly 24 for my chicken and hamburger. Oops, we need a Y on here. So now we can go to graph this. You can do this a couple different ways. You could find the intercepts if you really wanted to, since these are nice and pretty. If you plug in 0 for x, you get 10 for y. If you plug in 0 for y, you get 8 for x. So let's graph those. Over 0, up 10, here's 1 point. 8, 0, there's another. So since I could spend exactly $24, I'm going to make a solid line. And then I want all of these values to be less than this line. So this is where I'm going to shade everything below here. So then stop and think about what things could make sense. What points would work? If I want to spend no more than $24, any point in here would work. So that would be like this point right here would be 2 pounds of X, which is hamburger, and 3 pounds of Y, which is chicken. Or this one right here would be 1 pound of X, which is hamburger, and 7 pounds of Y, which is chicken. It could even be one of these points. 8 pounds of X, which is hamburger, and that's all the money I could spend. Or 10 pounds of chicken, and that is all the money I can spend. But any of these points work. So when it says find 3 possible combinations, list 3 points that are in that shaded area. So here is a story problem. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.